Hi, welcome to the Olympiad geometry. Let's continue our study on the Incenter. Before we start, if you think this video is helpful, please click the like button, comment, share, or subscribe the channel. Thank you. Here is the problem. In right triangle ABC, angle C is 90 degrees. CD is the altitude of edge AB. O1, O2 are in centers of triangle ACD and triangle BCD respectively. Prove that angle AO2C equals to angle BO1C. Before we think about the problem, I want to talk more about this figure because this is a very classic one. I believe a lot of problems, a lot of computations use this figure. So let's just try to get as much as possible we can get from this figure. Okay. So first, we know that angle ACB is 90 degrees, angle CDB is 90 degrees, angle CDA is 90 degrees. So we already know that triangle ACB is similar to triangle ADC is similar to triangle ACB, right? So CDB. Okay. And we already know that angle DCB equals to angle DAC, right? And because AO1 and CO2 are the angle bisectors, so let's just mark the equal angle with the same notation here, right? So, and we know this angle equals to this one equals to this one. Now we connect O1, O2 and extend it. Let's call this point as K, this point as L. Okay, so the first thing I want to talk about is that because angle O1AC equals to angle O2CB, right? O1AC equals to O2CB. And also angle O1CA equals to angle O2BC. So we know that triangle AO1C is similar to triangle CO2B, right? This one is similar to this one, right? And because O1D is angle bisector of angle ADC, which means angle ADO1 equals to angle O1DC equals to angle CDO2 equals to angle O2DB equals to 45 degrees, right? These four angles are equal. They are all equals to 45 degrees. So we know that based on this, right, we know that triangle AO1D is similar to triangle CO2D, right? This angle equals to this one. This is 45 degrees. This is 45 degrees. So the triangle AO1D is similar to triangle CO2D. And also triangle CO1D is similar to triangle BO2D, right? CO1D and BO2D, because this is 45 degrees, this is 45 degrees, this angle equals to this angle. So we got some information here, and now let's see. Based on the triangle AO1C is similar to triangle CO2B, so we can get that AC2CB equals to CO12 BO2, right? From this one, the triangle AO1C is similar to triangle CO2B. So AC to CB equals to CO1 to BO2. And from triangle CO1D, similar to triangle BO2D, we know that CO1 to BO2 equals to O1D to O2D. Right. And we already know that angle O1D O2 equals to 90 degrees and angle ACB equals to 90 degrees, which means AC to CB equals to O1D to O2D. And also the angle of ACB equals to angle O1D O2 equals to 90 degrees. So we know that triangle ACB is similar to triangle O1D O2. Right. Now let's look at angle AO1D. Right, angle AO1D equals to 90 degrees plus half of angle ACD. Right, that's a property of the incenter. We already proved that. Right, I told you this is a very, very useful useful property, so it should be keep in mind. So the angle AO1D equals to 90 degrees plus angle half of angle ACD. And we know that angle DO1O2 equals to angle DAC. Right? Angle DO1O2, this angle, equals to angle DAC, because this triangle is similar to this triangle. So what about angle AO1K? That equals to 180 degrees minus angle AO1D minus angle DO1O2, right? It equals to 180 degrees minus the summation of these two angles. So the angle AO1D, that's 90 degrees plus half of angle ACD. And angle DO1O2, DO1O2, that equals to angle DAC. So angle DAC. Right. And so let's see here. The 90 degree, let's see the triangle ACD. Right. 180 degree can be considered as a summation of the three inner angles. And 90 degree can be considered as angle ADC, right? Half of angle ACD, that's half ACD, and angle DAC, which means the rest of the part would be another half of angle ACD, right? So equals to half of angle ACD, which means angle AO1K equals to angle KCO1 or angle O1CD, right? So I'll mark it as this one. Similarly, we can prove that angle BO2L equals to angle O2CB. So I'll mark this as this one, which means that we already know that the angle, the twice of this angle plus twice of this angle equals to 90 degrees, which means half of them would be 45 degrees. So angle CKL equals to CKL, this one equals to half of angle CAD plus half of angle ACD equals to half of angle CAD plus ACD equals to half of 90 degrees, that's 45 degrees. And similarly for the angle CLK, it also equals to 45 degree, right? So we know that CK equals to CL. Also, because the angle KO1A equals to angle KCO, so we know that triangle KO1A is similar to triangle ACO1, right? Or let me write this. Triangle O1C KO1A O1CA. That's a better representative. So these two triangles are similar, right? So same thing for here. This triangle, the O2CB is similar to triangle, let me write it, O2CB is similar to triangle LO2B. Okay, so I derived a lot. Now let's look at the problem itself, right? So we want to prove that angle AO2C equals to angle BO1C. So let me connect AO2. And we connect BO1. We know that angle AO2C equals to 360 minus angle CO2B minus angle AO2B, right? And angle BO1C equals to 360 minus angle AO1C minus angle AO1B, right? The angle AO2C equals to 360 minus angle CO2B minus angle AO2B, right? So the angle CO2B equals to angle AO1C, that's 135 degree, right? The angle CO2B equals to angle AO1C equals to 135 degree, right? Why? Because this is 180 degree minus the rest, the summation of the rest of two angles, that's 45 degrees, so it's 135 degree. And that means we want to prove the angle AOC equals to angle BOC. Means that we want to prove the angle AOB equals to angle AO2B equals to angle AO1B, right? So if angle AO1B equals to angle AO2B, that means AO1, O2B are cyclic, which means we can prove AO1, O2B are cyclic first to show that the angle AO2B equals to angle AO1B, right? And to prove they're cyclic is pretty straightforward because the angle O1, O2B plus angle BO2L equals to 180 degree, right? And we already know that angle BO2L equals to the angle BO2L equals to angle BAO1. So we know that angle O1, O2B plus, because angle BO2L equals to angle BAO1. So we know that angle O1, O2B plus angle BAO1 equals to 180 degree, which means AO1, O2B are cyclic, right? These 4 points are cyclic, which means angle AO2C equals to angle BO1C. Okay, so in this video, we just derived some relations, figure out some relations and equations in this particular figure. This is a very, very interesting figure, and because we can find so many similarities in the triangles, and we can find we can get a conclusion that CK equals to CL regardless of the ratio of CA to CB, right? That's a very interesting phenomenon, and also we finally proved that A01, O2B are cyclic, and then we can prove what we want. So in next video, I will talk about the reversal version of this figure. I hope you like this video. See you in next one. Thank you.